Okay, brilliant. So, as I was saying, today's objective, inshallah, is that we are going to learn about something called. We've completed trig in school, and I don't find it too complex. What was all the hype about? All right, that's brave of you to say that. I mean, I could be wrong. Maybe you find it easy. So we'll find out. Have you done past paper questions as well as Jaffa? Yes or no, Jaffa? Have you done past paper questions as well? Two past paper questions. All right, that doesn't count. Okay, you can't judge the difficulty level of it. Yeah, you can't judge the difficulty level of a topic just by doing two past paper questions. I mean, for that, the same way I can say circular measure is also easy if you just do two past paper questions and we pick and choose and do the really easy ones. So you'll find out it is a challenging topic. Having said that, when I say something is challenging, that doesn't mean that I want you guys to struggle with it, but it's just that I want you guys to take it more seriously. Okay, don't think that it's very easy and you can learn it. I mean, you can learn it easily, but the whole idea is so that you keep on practicing it. Okay. Anyway, so today, inshallah, we are going to learn about something called basic angle, also known as alpha, and theta. Okay, now the whole objective behind learning this is so that we are able to solve trigonometric equations, but we're not going to do that immediately. But our practice have made circular measure quite easy. Yeah, that's the case with pretty much every topic, with everything, in fact. Okay, so yeah, as I was saying, what was I saying? Yeah. So we're gonna learn basic angle and theta for the objective behind is so that we can solve trigonometric equations. Now, as is, you may not be able to see the application of the concept that we are doing right now, but with practice, when we get to actual questions, you will be able to see exactly how the two relate. Okay. So right now you might have this question that how exactly are we going to use this, or what's the whole concept of what's the whole reason behind this concept, exactly like what you guys had earlier, okay, when we were studying quadrants. So here also you will have the same question that will bother you, but don't let it bother you for too long because you will find the answer to it. Okay, anyway, so here is something called basic angle, okay, which we're going to refer to as alpha and theta. And the symbol for that is, well, this is something that you guys know from before. And sometimes instead of theta, we will use x. Okay, so don't get confused. How many classes of trigonometry have we had? Today is the second class, Shahan. Today is the second class. Okay, so let's start with basic angle. Now, what do you guys know about basic angle? Basic angle, or like I said, we're going to refer to the basic angle as alpha. Normally, we refer to it as alpha, okay? But sometimes the question might refer it to as something else. So there are three main properties about the basic angle which you need to know. Number one is that it's always angle which calculator tells. Okay. Is that it's always positive. Okay, that's number one. Number two is that it's always acute. It's always going to be an acute angle. Okay, yes, good job, Shamir. And number three is how you make it. Okay, like where exactly or how exactly do we make alpha? That is property number three. Property number three is that it's always made with the horizontal axis. Okay, so alpha is the angle that you make with the horizontal axis. So here are your four quadrants. Okay, from 0 to 360. Alpha is the angle that will always be measured from the horizontal axis. Okay, could be the positive horizontal axis, could be the negative horizontal axis, but it's always going to be the horizontal axis. So this is how you're going to measure alpha. This is not how you're going to measure alpha. Okay, so keep these two properties in mind. Keep this property in mind, and that is it is always going to be measured from the horizontal axis. So let's write that down. Always measured from the horizontal axis. Okay, now this is basic angle. How exactly are we going to use it? Don't worry about that right now too much. Okay. Next is theta. Now, theta is the angle that is going to be our final answer when we're solving a trigonometric equation. Okay. Theta or x. So when you're solving a trigonometric equation, what you have as your final answer, that is what's theta going to be, or x, depending on how the question is structured. There you go. One thing I forgot, which nobody reminded me of, and that is writing the date. There you go. Okay. Theta. What do you guys know about theta? Again, three properties. 1, 2, 3. Property number 1 is that it's always measured angle in degree. Okay. Okay. But that's not exactly a property because it's not always going to be in degrees. By the way, do keep that in mind. It's not always going to be in degrees. It could be in radian. Okay. Again, depends on how the question is structured. So that's not exactly a property. All right. Try again. Anyone else? No one? Okay. I'll explain. So, very good. Very good. So, property number 1 is that it's always measured from the positive horizontal axis. Okay. And what you're saying is property number 2. And property number 2 actually has 2 parts. Okay. And the 2 parts are what you're saying. So, and this is where most students generally struggle. Yeah, okay, this is the final angle, okay? With the help of alpha, you calculate the final angle, which is theta or x, but that's not exactly a property of this angle, okay? That's just something we keep in mind. So basically, this angle is always measured from the positive horizontal axis, okay? So like for example, if this is 0, this is how you're going to measure the angle. Or you can also measure it in a clockwise direction as well. Now, what is the difference? Is it both going to be the same? No, it's not it's not going to be the same irrespective of how you measure it. It's going to be different. How is it different? Let me show you with the help of an example. Now let's say this is 20 degrees. This, by the way, is alpha. Okay, so why is it alpha? Because it's made from the positive horizontal axis. So if this is 20 degrees, let's see what is the impact if we measure it in a clockwise direction and if we measure it in an anti-clockwise direction. But a property to keep in mind is this, 2a. Property 2, part A, and that is it's going to be positive if you measure it in an anti-clockwise direction. Okay, now it's counterintuitive. Normally you might think that if it's clockwise it should be positive, if it's anti-clockwise it should be negative. That's not how it is. Okay, it's the other way around. Part B, which is it's negative if you measure it in a clockwise direction. Okay, so what does that mean? That means if I measure this angle, let me use a different color for both the directions. Okay, let me use green for anti-clockwise and some other color for clockwise. So if this is 0, okay, and this is a straight line, what do you think this angle will be if I measure it in a anti-clockwise direction? What is the value going to be? 160. Very good. It's going to be 160 degrees. Okay. But if I measure it in a clockwise direction, okay, so a lot of times people immediately take into consideration that it's going to be that they have to take into account the negative sign. Okay, yes, you do have to take into account the negative sign, but when you're measuring the angle, just measure it like you would measure any other angle. Okay, no, it's not going to be minus 220. Yes, it's going to be not 200, but it's going to be minus 200. So here's what I'm saying. Measuring it in a clockwise direction means this is the angle that you want. Okay, so what is this angle going to be? You can just break it down into 2. Up until here it's going to be 180, then there is another 20 degrees to go, but because you have done it in a clockwise direction, it is now going to be minus 200. Okay, so minus 200 if you do it in a clockwise direction, and 160 degrees if you do it in an anti-clockwise direction. Now at this point, you may be wondering that how will we know whether we have to measure it in a clockwise direction or an anti-clockwise direction? And my answer to that is don't worry about it right now. You will find the answer to it. Okay? All right. Now, Reason number three. Reason number three is just something to watch out for, and that is it has no fixed range. It can be more than 360. It can be negative. It can be even less than negative 360. So it has no fixed range. The range depends on the question itself. Okay, we'll see about that later on. Yeah, so these are the three properties. Let's just go over them one more time. Three properties of alpha or your basic angle is that it's always acute, always positive, and always measured from the horizontal axis. Theta, on the other hand, is always measured from the positive horizontal axis. You can see that whatever angle it is that I'm measuring, this is the starting point, the positive horizontal axis. And if it's positive, it's going to be in an anti-clockwise direction. And you can think of it the other way around as well. If you're measuring it in an anti-clockwise direction, it's going to be positive. If you're measuring it in a clockwise direction, that means it's going to be negative. Or if it's negative already, that means it must have been calculated in a clockwise direction. Somebody's mic is open. Taken care of. Oh, okay. And property number three is that it has no fixed range. Okay. So what we're going to do right now is we're going to do an exercise where we're going to learn how to calculate theta with the help of alpha and the other way around. Okay. And even now, you will not be able to understand where or how we're going to use it. That's not important right now. Things will come together, inshallah, in the end. Not like the very end, but they will come together very soon. Okay.
So what do you mean by no fixed range? Do you mean like the angle's fixed range or something else?
Yeah, I mean the angle fixed range, the range of theta. Theta has no fixed range.
Isn't 360 the maximum?
No, it can actually go beyond 360 as well. When you go a cycle further, one cycle is 360, but when you go a cycle further, it can go beyond 360 as well. Okay, we'll see about that when we're dealing with questions now. We'll see about that, and we will connect this. We will connect this with graphs. Okay, if you remember, I said in the first class that trigonometry is basically studied in a circular pattern. To understand equations, you have to understand graphs. To understand identities, you also have to understand graphs. So we're just going to do this in a circular pattern, and I'm pretty sure, inshallah, you guys will enjoy it. Okay, because when you understand it, you will enjoy it, inshallah. All right. So here's an example. Let's say you're given alpha. Okay, you're given that alpha is equals to 45 degrees. Okay, and this alpha is present in all four quadrants. Okay, and the range of theta is from 0 to 360 degrees. Okay, and what you have to do is you have to find theta. Now remember, in order to find theta, whenever you're solving a trigonometric equation, you do that with the help of alpha. Okay, so first thing you're going to do is, let me solve this example for you guys from scratch so that you know exactly how a question like this will be attempted. So here are your four quadrants, all right? And here we have alpha 45 degrees, which like I said is in all four quadrants, okay? 45 degrees, 45 degrees, 45 degrees, and this is also 45 degrees. Okay, and what's the range of theta? As you can see, the range of theta is from 0 to 360 degrees. Okay, now you might think that this is contradicting what I said earlier. I said earlier that theta has no fixed range. Here I've given you a fixed range, and that is from 0 to 360. Now, in other question, you might have a different range, which could be from 0 to 180, and in other question, you might have a different range, which could be from 0 to 720. So theta naturally has no fixed range. Okay, the basic angle alpha naturally has a fixed range, whereas theta does not. Okay, so it will vary from question to question. Okay, now what you have to do is you have to measure theta. Okay, so how will we start? Remember, the first property is that it's always measured from the positive horizontal axis. Okay, so that means this is, let me highlight it for you guys, this is from where we will start measuring theta. Number two is that if it's positive, that means we will do it in an anti-clockwise direction. Okay, so is it positive? Let's look at the range. It's from 0 to 360. That means it is positive. That means we will do it in an anti-clockwise direction. Now the question is, what exactly are going to be the values? Now, if I ask you guys, just a simple question, how many values can you expect here? How many values do you think we'll get? Sir, why is your screen a bit laggy today? Is my screen lagging? It's fine. Okay. All right. So I'll just quickly stop sharing it and I'll share it again. All right, so maybe that will help. I hope it does. If it doesn't, then I think the problem sadly is at your end. Okay. What did you guys say the answer to my question was? 4. Yeah. So we're going to get 4 values. That is correct. We're going to get 4 values. All right. Now, how exactly are we going to get those 4 values? Here's how we're going to get those 4 values. It's a lot like bearing, if you guys remember bearing. Bearing, we used to start from the north, okay, and we would go in a clockwise direction. Here we start from the positive horizontal axis and we go in an anti-clockwise direction, and we keep on going till we reach alpha. So this is the first value of theta. And what do you think this is going to be? This is going to be 45. Good job. So 45 degrees. Okay. Next, we start again from the positive horizontal axis. We keep on going till we reach alpha. That's in the second quadrant. What is this going to be? This is going to be 180 minus 45, which means it's going to be 135 degrees. Okay. What about the third quadrant? Again, we start, we keep on going, and this is where we stop. What is this going to be? This is going to be 180 plus 45, which is equal to 225 degrees. Okay, and the fourth one, can you guys figure that out yourself? Although the previous ones also, you figured it out yourself. Yep, it's going to be 360 minus 45. Good job, fellas. So that is going to be 315 degrees. And there you go. And with the help of this, you know what we're able to do? With the help of this, we're able to come up with a standard rule for 0 to 360 degrees, through which we can calculate theta from 0 to 360 degrees if you have alpha in all 4 quadrants or in any of the 4 quadrants. Okay. And what is that standard rule? Let's look into it. Now, I don't want you guys to get too fixated on the standard rule. Okay. I don't want you guys to try and put in a lot of effort to memorize what the standard rule is, because it's simple common sense. Okay. You don't really have to have the standard rule in order to find out what these angles are, but still, I'm just going to give it to you guys so that if you find it somewhere, you know exactly what if you find it in some book, you know exactly what it's talking about. Okay. So let's generalize it. This is alpha in the first quadrant. This is alpha in the second, third, and fourth. 0, 90, 180, 270, 360. By the way, I forgot to do that over here. Remember, it's very important. 0, 90, 180, 270, 360. And this is not 0 divided by 360. It's 0 slash 360, depending on how you're looking at it. Okay. Okay. So what is theta going to be in terms of alpha in the first quadrant? In the first quadrant, theta is going to be equal to alpha. Okay, so in the first quadrant, theta is equals to alpha. Okay, in terms of alpha. Iman, 45 is correct. Okay, but this is the standard rule that we're now looking into. Okay, this is the standard rule that we are now looking into, which, although I'm giving it to you guys, but like I said earlier, I don't want you guys to get too hung up on this rule. Okay, the second, what is theta going to be in the second quadrant? 180 minus alpha. Very good. So in the second quadrant, theta is going to be 180 minus alpha. What about the third quadrant? What is theta going to be? 180 plus alpha. Okay. What about the fourth quadrant? 360 minus alpha. Yes, Shamira, I guess that's what you were trying to say. But yeah, that's correct. Alpha is equals to 360 minus alpha. Okay. Now, if you think about it, these standard rules, if I didn't give you the standard rule, would you have not been able to calculate theta? Yes or no? What if I didn't give you these standard rules? No, exactly, because it's common sense, right? You know the 90-degree angle, you can see the 180-degree angle, it's a straight line, and you can see the full circle because which means it's 360. And yeah, through that, you can find out theta. Okay. So let's do some more examples. Like I said, the whole objective of these examples would be to get familiar with the calculation of theta with the help of alpha and the other way around. Okay. Now, here we go. This is, take a good look at it, by the way. Anyone wants to take a screenshot or whatever, go ahead. All right. Now, moving on. Example number 2. So here, this is what I want you guys to do. In fact, we're going to do this together. Then I'll give you guys some questions to solve. For each of the following, for each of the following values of theta, find alpha. Okay, find alpha, or I should say specifically find the basic angle. Okay. Now here's the first part. First part is theta is equals to 120 degrees. Okay, so theta is 120. It's positive 120. That means A, we are going to start from the positive horizontal axis. We're going to do that irrespective whether it's positive or negative. And B, we are going to measure it in an anticlockwise direction. So where do you think I'll land if I measure 120 degrees in an anticlockwise direction from the positive horizontal axis? Meaning, will I land in the first quadrant, second, third, fourth? I'll land in the second quadrant. That is correct. Okay. So this is what it's going to look like. It's always a good idea to sketch it. Okay. With every topic, you would have noticed me emphasizing on the sketching part, and that's because it gives you more clarity. It doesn't have any marks, let me give you that, but it gives you a lot of clarity. Okay, so this is what it looks like. All right, and the 120 degrees, this is what that looks like. Theta is equals to 120 degrees, and always a good idea to label 0, 90, 180, 270, 360. So that means alpha is going to be this angle right here, correct? Trick question. Yes, no. This is what alpha is going to be. Why not? What's wrong?
It's must be with the horizontal axis.
Yes. Okay. So a lot of times people forget the fact that alpha is not just acute. It's acute, positive, and also measured with the positive horizontal axis. So this is what's alpha going to be. Okay. Now you don't need a lot of yes, mom, and your answer is correct. You don't have to be a rocket scientist to be able to calculate this. All you got to do is use some basic trigonometry. And what is this angle going to be? This is going to be 180. And from 180, what you have to do is you have to minus alpha, and that will give you 120. Or in other words, from 180, subtract 120, and you will have alpha. So what is alpha going to be equal to? Alpha is going to be equal to 180 minus 120, which means 60 degrees. That's it. No, wait a minute. Yeah, 180 minus 120, which is 60 degrees. Okay. So take a good look at it. Let me know if you have any questions. Like I said, don't worry too much about how and when we're going to use it. We're going to get to that. When we get to that, you'll find the answer to that. Okay, so let's do another question. Theta is equals to 200 degrees. Where will this take us? In which quadrant? In the third quadrant. Very good. Okay. Now, when I said not get too fixated on the standard rule, here's what I meant. I don't want you guys to refer to this diagram again and again to find out what alpha is going to be. Just use your common sense. Okay. So this is from where we will start. This is 90, this is 180, 200 degrees. This is what that means. Okay, let's mark 200 degrees. This is what it looks like. Theta equals to 200 degrees. What do you think about, okay, already answered that. Good job, Iman. And that is, what is this alpha going to be? It's going to be 20 degrees. Now, how did I figure that out? Again, no rocket science. This is 180, and the red angle that you're looking at is 200, as mentioned in the question. So if you want to find out alpha, just do 200 minus, 200 minus 180. And there you have it. It's 20 degrees. Okay, all good so far? I hope you guys are getting the hang of it. All right, cool. Okay, part C. Theta is equals to 300 degrees. Can you guys give this one a shot? I'll zoom out so you have a clear picture of what you're supposed to do. There you go. $60 is the correct answer. Yeah, so 60 it is. Alpha equals to 60 degrees. Good job. Okay, so 300 will take you in the fourth quadrant, and alpha would be the small angle that is made from the positive horizontal axis. In between the positive horizontal axis and theta, subtract 300 from 360, and you will have 60 degrees. Okay. Now the thing is, when it's positive and when it's in between 0 and 360, it's kind of easy to figure out. Okay, why? Because you have the standard rule. Okay, and not only just the standard rule, because like I said, don't refer to the standard rule over and over again, but it's kind of easy because things are pretty much under control. But things get slightly complicated if you have theta that's exceeding 360 degrees or when it's in negative. Okay, so let's do a few examples. If theta exceeds 360 degrees, what do you think will happen if let's say theta is equals to 400 degrees? How exactly are you going to measure 400 degrees?
360 plus theta.
360 plus theta or 360 plus alpha actually. But let's see what it's going to look like. What is theta equals to 400 degrees when measured from the positive horizontal axis in an anti-clockwise direction? Let's see what that is going to look like. So basically, this is what it's going to look like. You start from here. This is 90, 180, 270, 360. But because theta is more than 360, that means you go slightly beyond 360. Okay, but in which quadrant do you end up? You end up in the first quadrant. Okay, you end up in the first quadrant again. Okay, let's have a look at it one more time. So 0, 90. Let me label this to give you guys more clarity. 0, 90, 180, 270, and 360. Yeah, so let's do this again. So theta equals to 400 means that we started from 0, 90, 180, 270, 360, and then 40 degrees 400 means 40 degrees more than 360, and 40 degrees more than 360 takes you where? Takes you in the first quadrant. Okay, so this is what it looks like. Random question: how does a 400 degree angle looks like? This is what it looks like, exactly right in front of you. This is what it looks like. Okay, although you don't measure an angle and have it 400 degrees, because that means it's 40 degrees. But when you're solving trigonometric equations, you have angles more than 360 degrees. Okay, and we'll see why that is. We'll see exactly why that is when we're looking at graphs. Okay, yeah, so it is 40. How exactly do we get 40? So within the first quadrant, that means if I want to find out alpha is going to be the angle that's formed between theta and the positive horizontal axis, which is the angle that I've highlighted in green. Now, what should I do if I want to calculate this angle? Here's what I need to do. I need to take this entire angle into consideration, which is 400, and from 400, I need to subtract this angle, the one that I've highlighted in blue. Okay, so that will give me alpha, which is going to be 400 minus 360, which means alpha is equals to 40 degrees. Okay, so take a good look at what I've done. Let me know if you guys have any questions at all. So can you explain what theta would be here? So theta we're given as 400. So with the help of that theta, we're measuring what alpha is going to be. 20 is, let me check. 20 is the correct answer. Good job. 20 is the correct answer. Okay. How? Let me solve this this one for you guys as well. So 520 degrees. So 520 degrees means that you've gone a full circle and beyond. Okay. Yes, it's going to take you in the second quadrant. So this is what it looks like. So we start from the positive horizontal axis. Okay. Yes, Reach, good job. This is a full circle, 360. Now you got to be careful. Okay. So this is 0/360. Now, if you go more than one cycle, so that means this is 90. But if you if you take this to be your 360 degrees, then this becomes 360 plus 90, which means it becomes 450. Okay, this is 180. But if you do 450 plus 90, that means it's 540. Okay, and this is 270, although we don't need this, but if you do 540 plus 90, it's going to be 630 degrees. Okay, so it's 360 degrees up until here, but 540 means this is 440. Sorry, 520 means in between 450 and 540. So that means it's going to be somewhere over here. Okay, all right, I'll explain this again. Let me erase this. Let me erase this. Let me just erase this as well. So first of all, understand what cycle 520 degrees is going to be. It's going to be the second cycle. Okay, so this is 0, 90, 180, 270, and 360 degrees. Okay, now 90 degrees more than 360 means 450 degrees, and 90 degrees more than 450 means 540 degrees. So that means 520 is going to be in between 540 and 450. Okay, so what quadrant is that? That's what's important. This is the second quadrant. So here is 0 to 360, then 450, and then slightly beyond 450, and before 540 degrees. So that means this is what theta looks like. Okay, now if I want to find out alpha, that means this is the angle that I have to calculate. Now there are a lot of ways through which you can do this. You can do 360 minus 520 minus 360, which will help you find out what this angle is, and then with the help of this angle you can then calculate alpha. Or here's what you can do. You know that if, let's say, you had gone further than 500 and for more than 520 degrees, okay, until the end of the second quadrant, it would have been 540 degrees. And now from 540 you need to subtract 520 degrees in order to find out what this angle is going to be. Okay, so how will I find out alpha? 540 degrees, which is basically the angle from here. Let me draw it separately, which is basically the angle, the angle in purple. Okay, and from that we are going to subtract 520 degrees, which is the angle in red, and that's going to give us 20 degrees. Okay, another easier way, if you don't want to get lost in 500s and 400s and all that, here's what you can do. Okay, 520 means what cycle are we in? We're in the second cycle. Okay, so if you want to see how many degrees are we into the second cycle, what can you do? Simple calculation. What you can do is you can do 360 minus 520. Okay, so what's 360 minus 520? Question for you guys. What's 360 minus what's 520 minus 360? 520 minus 360, that is 160 degrees. So what that means is, that means you are 160 degrees into the second cycle. So that means this, if you start counting from 360 degrees, this is not theta, but this angle is 160 degrees. Now how does this help? This helps you in calculating what alpha is going to be, because now you know that this is a straight line, which is 180, and all you got to do is from 180 subtract 160, so that you have alpha all over again. 180 minus 160, which is 20 degrees. Okay, so doesn't matter how you do it, with the passage of time you guys will realize what works and what doesn't, and why uh, why why I will pick one method over the other. You'll find that out. Okay, by the way, when will we start differentiation? When will we end functions? Okay, I think you guys know what the sequence is. I've shared it multiple times, so it's best if we focus on what we're doing. Okay, I've told you guys that we're going to do trigonometry, then we're going to do functions, then we're going to do differentiation and integration. Okay. So what if we? No, don't get hypnotized. Okay, we are eventually going to ditch this approach, and we're going to move to a slightly better approach when it's more than 360 degrees. Maybe then. Okay. So I'm going to give you guys, in fact, wait a minute. Let's do a couple of examples of negative angles, and yeah, then I'll give you guys some questions to solve. Okay. So this is going to be part EF. Yeah, that's going to be part F. Here, theta is minus 150 degrees. I accidentally drew a swastika during. So you use that to do rotation in O-level math. Yeah, but don't forget to erase it once you're done doing that. And you know what? I've actually seen that method in some books as well. Okay, so you don't have to associate that shape with whatever history it has. In fact, this happened with one of my friend. He had dengue, so the administrator brought a form to him and gave him the option of extra time. Really? Isn't that something you have to inform beforehand? No, I'm not doubting that it happened. I'm just saying that, as far as I know, that is something you have to inform beforehand. Alpha equals to, yes, good job, Samaria. And yes, it's going to be in the third quadrant. So basically, this is minus 150 degrees. So that means here's 0. Now, minus 150 means that we're going to measure it in a clockwise direction. Okay. So that means if I move from 0 to here, this is going to be 90 degrees in value, but because we're doing it in a clockwise direction, it's going to be minus 90 degrees. And this is going to be minus 180 degrees. This is going to be minus 270. And it's going to be, this is going to be minus 360. Why? Because it's negative, because clockwise. Okay. Now, don't worry too much about the negative value. Okay. Minus 150 degree means what? Minus 150 degree means that we are going to measure 150 degrees, but we're going to do it in a clockwise direction. So here is 0 from where we'll start. This is minus 90. This is minus 180. That means 150 degrees is going to be in between minus 90 and minus 180. Okay. So what does that mean? That means this is theta, which is equal to minus 150 degrees. Now the question is, what is alpha? Alpha, as we know, you guys are making an error, most of you, not all of you. What we have to measure is alpha, which we know is always positive. Okay, emphasis on positive, always acute and always measured from the positive, from the horizontal axis. Okay, so you guys are making that error. Minus 30 is partially correct. It is going to be 30, but it's not going to be minus 30. It's going to be just 30 degrees. Okay, so this is what alpha is. Remember, it's measured from the horizontal axis. It's always acute. It's always positive. So it's going to be 30 degrees only. Okay, not minus 30 degrees. Okay, so take a good look at it. Let me know if you have any questions, sir. But isn't clockwise negative? So clockwise theta, when you measure it, it's going to be negative. We are calculating alpha. Okay, with alpha, there's no direction associated with it. Go back to the properties. With alpha, there is nothing related to the direction. So minus 180 plus 30 is minus 150, but we need this answer in, okay, like I said, don't let the minus sign bother you too much. What I want you to do is, when calculating alpha, is this. What is this angle going to be in value? Forget about the direction. Okay, for the direction, you just need to take into account how you measure it, which we've already done that. Okay, we've already figured out theta correctly. We've already, you can say, marked theta correctly. Now we're talking about calculating angle. Okay, calculating alpha. So what is this angle going to be? This angle is going to be 180 degrees. Okay, now what is this angle going to be? It's going to be 150 degrees. Okay, yes, minus 150, but we've already taken that into account by measuring it in a clockwise direction. Now we're doing simple calculations for which we're not going to let the negative sign bother us too much. So here's an angle which is 180, and here's an angle which is 150. You need the angle in between. What is that going to be? That's going to be 180 minus 150, which is equal to 30 degrees. Okay, Faiz, does that help? Let me do another example. So that it clear things out. It can clear things out. So let's say that you have theta, which is equal to minus 200 degrees. Okay, now a lot of times students let the minus sign bother them too much. So please don't let that happen to you. In fact, not minus 200, because we've done an example similar to this. Let's say that it is minus 250 degrees. Yeah, minus 250 degrees. Okay. So with the minus sign, just remind yourself that you will have to measure this angle in a clockwise direction. That's it. That's the only thing that I want you guys to worry about. Okay. Everything else will just take care of itself. So here's 0. Here's minus 90. Here's minus 180. Here is minus 270. And here is minus 360. Yes, Ubaidullah, your answer is correct. So minus 250 means here's 0, here's 90, here's 180, here is 270. 250 means that it's going to be just before negative 270. Okay, so this angle that you're looking at, this is theta equal to 250, but with the negative sign, because we've done it in a clockwise direction. Okay, now what is alpha? Alpha is this angle. Okay, So when I'm calculating alpha, I am not worried about the negative sign or anything like that at all. Here's what I'm going to do. I'm going to see what this angle is in value. What is this angle in value? This angle in value is 250 degrees. And then from this, I need to subtract this angle. Okay, which is what? Which is 180. So 250 minus 180, which is equal to what? Which is equal to 70 degrees. And that is the value of alpha right there. There you go. That's your answer. Okay, so don't let the minus sign, we only take into account when we are placing theta, okay, and when we are measuring it. And we need to keep in mind that we have to do it in a clockwise direction. But after that is done, when you're calculating alpha, forget the minus sign, just do it with normal values, just like how you would measure any other angle. Okay, so as always, take a good look at it. Let me know if you have any questions. If you don't, I'm going to give you guys some questions to solve without my help. Okay. So here's part H. So this is just going to be a mixture of everything. Okay. 370 degrees. I minus 250 degrees. You guys have to tell me alpha. Okay. J. How many more? We're going to keep on doing it till you guys get the hang of it. Actually, I'm just kidding. So this is it. Then we're going to move on to trigonometric equations. Okay, we're going to do some graphs. We're going to get like a basic understanding of graphs, and then we're going to move on to trigonometric equations. Okay. Okay, just do these three. I think these should be enough. So I'll give you guys 3 minutes to figure this out. Oh yeah, thank you for pointing that out. So I'm just going to change this to minus 300. I can't tell is J 200 and yeah, it's 210 degrees. Yes, it's 210. Minus 40. Yeah, it can look like minus 40 as well. I'll just write it again. Minus 210. There you go. Okay. 10 is correct. For 370, it's going to be 10 degrees. I think most of you have gotten that right. So for this, it is going to be 10 degrees. Okay. For part I, let's see, it's minus 300. So for this, it's going to be 60 degrees. Yes. So minus 300 will take you to the first quadrant. Okay. Now, if it takes you to the first quadrant, that means alpha is now the acute angle that is formed. So here's 0, here's minus 90, here's minus 180, here's minus 270. This is going to be a full circle in a clockwise direction, which means it's going to be minus 360, but minus 300 means this is what we're talking about. Okay, so if this is minus 300, okay, then what is alpha going to be? This is what alpha is going to be. So it's going to be, what do you guys think? It's going to be, this is going to be 60 degrees. Okay. Now, then we have minus 210. For this, the answer is 30 degrees. This, I think, pretty much all of you got right. So, good job. Okay. Now, any questions? I hope this concept is now clear. Now you will see this concept actually coming to life when we use it to solve trigonometric equations. But before that, we're just going to have a little sneak peek into trigonometric graphs so that you're able to understand trigonometric equations better. So any questions so far? Yes, no? Okay, no question. Let's just take a 2-3 minute break. Okay. I'm just going to grab some water. And when we come back, we are discussing trigonometric equations. Before that, we're going to do a sneak peek into, like I said, trigonometric graphs. Okay. All right. So let's take it's 5:29 right now. Let's take a 5-minute break. Okay. So we'll resume at 5:35. Okay. So see you guys in 5 minutes, 6 minutes actually. Okay. So like I said, we are gradually entering into solving trigonometric equations. Okay. But having said that, what we are going to do is first we're going to have a look at the graphs of trigonometric functions. Okay, so this is what it looks like, and we're not going to have like a deeper look. We're just going to have an introduction to it, and then we will take a closer look when we're doing graphs in detail. Okay, so let's start with sine x. So have you guys seen the graph of sine x before? Yes or no? Yes? Okay. How come? No? Okay. Nothing to worry about. So basically, this is what the graph of sine x looks like. Oops. From 0 to 360 degrees. Sorry. 0. Okay. So this is what the graph of okay, so for those of you who have done this already, you guys would know exactly what the graph of sine looks like. For those of you doing it for the first time, well, this is what it actually looks like. Okay. Now, notice something about this graph is that it's very repetitive. Okay. Now, what do I mean by that? That means this from 0 to 360 we call one cycle. Okay. And then from that point onwards, it just continues forever. Okay. And it literally continues forever. It never stops. Okay. So, which is why every time you're asked with other graphs as well, every time you're asked to make a graph, you're always given a certain range of x. Okay. So you know where to start and where exactly you need to stop. Okay. So this is what the graph of y equals to sine x looks like. Let's quickly have a look at the graph of y equals to cos x as well. Then we're going to do some trigonometric equations. Okay. And then I'll show you how they're both connected. So this is what the graph of cos x looks like. Very similar to the graph of sine x, except that this starts from 1 instead of 0. Okay. So with that in mind, let's say that this is the equation that you're asked to solve. Just a minute. Yeah, the graph of tan is interesting. Like I said, we're gonna do graphs in detail. Okay, right now I just wanted you guys to have a introduction to it. Okay, so solving trigonometric equations. So an interesting thing with a trigonometric equation, which not a lot of people pay attention to, is that you're always given a certain range. So let's say you're asked to solve sine x equals to 0.5, and you will notice every time you're given a trigonometric equation, you're given a certain range, which we don't see otherwise, which we don't see in linear equations, we don't see in quadratic equations, we don't see in exponential equations. Okay, so let's say you're given a linear equation. Okay, so what does a linear equation look like? Let's say this is what you have to solve. 3x minus 5 equals to 1. So can we solve this? Yeah, like the back of your hand. 3x equals to, I mean, we know this, questions like these like the back of your hand. 3x equals to 6, x equals to 2. Okay, not that difficult. Now, what about a quadratic equation? Let's say you're asked to solve a quadratic equation, which looks something like this. X squared equals to 9. Now, what are the solutions to this? What will be the solution? Plus 3 and minus 3. X equals to plus and minus 3. And let's say that you are asked to solve an exponential equation, okay, which looks like 3 power x is equals to, let's say, 9. What will be the solution to this? Okay. It's going to be 2, not 3. It's going to be 2. Okay, why? Because 3 power x can be written as 3 squared. And if you cross this out, you have x equals to 2. Okay. And that's it. Okay, one solution or two solution. Okay, and what exactly does this solution, when we say solution, what does that mean? Let's use graph for that. Let's use graph to understand that. So when we say solution, x squared, let's take x squared equals to 9. Okay, so y equals to x squared and y equals to 9 are basically two graphs. And what we are interested in finding out are basically the point where they are intersecting. So let's take this from minus 10 to 10. Okay, let's zoom this in a little. Let's change the scale of y from 1 to 10. Okay, and then x squared equals to 9 means you want to find out when is x squared equals to 9, or in other words, when is the graph of y equals to x squared crossing or meeting the line y equals to 9. And we can see that we have how many solutions? We have 3 solutions, minus 3 and positive 3. Okay, so that's the reason why we get what we get, and that is plus minus 3. The same thing can be said about 3x equal to 9. If we change that, if we change this to 3 to the power of x, okay, and 9, you can see that we just have the one solution where x is equal to 2. Okay, and that's it. You can extend both the graphs as much as you want. They will never intersect again. But when we say sine x equals to 0.5, why is it that the question feels the obligation to give us a certain range? What do you guys think? We don't see these kind of ranges in linear, exponential, or quadratic equations, but why in a trigonometric equation? Question for you guys. Think about it. Only first what? Rotation. How does Okay. So what do you think will happen if the question didn't give us the range?
So because we are over here, we are calculating the angles, and angles are like they have no range. So the question has to specify us like what our answer should be.
No, that's what my question is. What do you think will happen? Let's see, sine x equals to 0.5. That means we want to see when do the value of x can't exceed 360. Okay, I agree with that, Reach. Nothing wrong with that. But my question is, what do you think will happen if the question didn't give us the range? That's what my question is. Simple. What will happen if the question... Sorry? Yes, exactly. Because if the question didn't give us a range, what will happen is that we will have infinite solutions. Okay, if the question did not give us a range, we will have an infinite solutions. Let's take a look at it as well. Let me clear. We take the appropriate values. Okay, yeah. So let me hide this for a minute and focus on just the graph. The graph would go to positive. Yeah, so exactly, that's correct. What you guys are saying is correct. So basically, sine x equals to 0.5 means we're trying to see this line we're making for reference. We're trying to see when exactly is sine x equal to 0.5. Okay, and we can see that once it's equal to 0.5 at 30, then it's equal to 0.5 at 150, then it's equal to 0.5 at 390, and then it's equal to 0.5 at 510, then it's equal to 0.5 at 750, then it equals to 0.5 at 870. And what happens is this never stops. Which is why it's very important that whenever you're solving a trigonometric equation, you have to have a certain range. Why is this not important with a linear equation? Why is this not important with a quadratic equation? Why is this not important with an exponential equation? Is because we only get finite solutions with the three kind of equations that I mentioned earlier. With an trigonometric equation, we get an infinite number of solutions, which is why to limit that, there will always be a certain range provided. Okay, so this is a question that not a lot of people wonder why you get a range with trigonometric equations. So, but it's something that I just like to explain anyway. So I hope it's clear. I hope you guys know why a certain range with a trigonometric equation is important. Okay, because we can see through graph that if the question did not give us a range, we wouldn't know when to stop. Now with the help of this range, we know exactly when to stop. Okay, so now we're going to solve this trigonometric equation, and there are 3-4 steps that we follow. If you've done this in IGCSE, you would know exactly what those steps are. If you haven't, then this is going to be new for you, and it's not that difficult. Okay, if you do it step by step, as it is with everything, if you do it step by step, it's not that difficult. Okay, so first of all, sine x equals to 0.5. So sine x equals to what? Sine x is positive. Forget 0.5. What's more important is that it's positive. Now, where is it possible for sine to be positive? That means in which quadrant can sine be positive? First and second. Good job. So the first step is that you determine the possible quadrants. Okay, so have we done that? Yep, we've just done that. We know that sine x is positive in the first and the second quadrant. Okay, now what does that mean? That means here sine, it's positive, which means it could be in the first and the second quadrant. Okay, that means you can have theta somewhere over here, and you can have x. Theta, by the way, x, by the way, is replacing theta over here. Okay, this question could have been sine theta equals to 0.5. It's sine x equals to 0.5. So don't get confused. It's the same thing. So this is step one. Step two is, hang on, let me just mark these. Let me mark the range 0, 90, 180, 270, 360. Okay. Step two is that you find alpha. Okay, but you don't just find alpha. Okay, you find alpha how? By taking the inverse of the positive value. Okay, now this value is already positive. This is already sine x equals to 0.5. But what if it was sine x equals to minus 0.5? Then what you would have done is you would have done sine inverse of 0.5. Okay, if it was minus. But because it's already positive, you don't have to worry about it. So what's sine inverse of 0.5? Make sure that your calculator is in degree mode, because in trigonometric equations, you will have some questions in degree like this one and some question in radian. Okay, so you have to keep your eyes and ears open. So sine inverse of 0.5 is equal to what? Is equal to 30. So we have our alpha right here. Alpha is equals to sine inverse of 0.5, which means alpha is equals to 30 degrees. So here's 30 and here is 30 degrees. Okay. Step 3, the final step. What is that going to be? Step 3 is that you find theta or x depending on the question. Now, how do we calculate theta? How do we calculate theta? Now we know how we calculate theta. What we do is we always start from the positive horizontal axis, and depending on the sign, depending on the range, we choose a direction. So what's the range over here? It's from 0 to 360. So what is the direction we're going to choose? The direction that we're going to choose is anti-clockwise. So what is this going to be? This is going to be 30 degrees. So one angle of x is 30. This is not theta, sorry. I'm just going to replace it with x. What about the other angle? What is this angle going to be? How exactly are we going to measure this angle? Question for you guys. Which is 150 degrees. Okay. So what have we just done? We have found out the possible values of x. Okay, where sine x is equal to 0.5. Now, if you want, you can cross-check. How? Very simple. Pick up your calculator, find out sine 30. You will notice it's 1 upon 2. Here, I hope you guys can see my calculator. Yeah. And then find out sine 150, which you will also notice is 1 upon 2. And that's it. This is how you solve a trigonometric equation. Now, as it is with every time you learn a new concept, one example I know is not enough, but this was just to give you guys an introduction. You don't have to write these steps every single time you solve a trigonometric equation. Okay, this we're just gonna do once, and then we're just gonna keep on referring to it. So, any questions? Sir, please give a quick recap. Yeah, I'll give you a detailed recap. Don't worry about that. So, first of all, just hang on a minute. There's azan going on in the background. Let me just wait for it to finish, then we'll resume. Okay. So, I'll give you guys a quick recap. Step 1. Okay, so there's before you start solving, although we don't have to worry about that right now, but before you start solving a trigonometric equation, just like with an exponential equation, first you have to make sure that it's written nicely. You have a base raised to a certain power equals to a certain constant. With trigonometric equation also, you might have to do this step, which you didn't have to over here. So sine x equals to 0.5. What's the range? The range is from 0 to 360. Why do we have a range? We saw earlier, because if we didn't, we would have had infinite solutions. Okay, so that means we need to find out when is the graph of sine x equal to 0.5, which we can see with the help of the graph that it's equal to 0.5 at 30 and 150. But the question is, how exactly are we going to do that without the help of the graph in front of us? So first thing, you see whether sine is positive or negative. Okay, sine x equals to positive 0.5. That means, or this sine x is going to be in between 0 and 180. Why? Because it's going to be the first or the second quadrant. So first quadrant is where all trigonometric functions are positive. The second quadrant is where only sine is positive. So it has to be the first and the second quadrant, which means that our final answer will be, one answer is going to be in between 0 and 90 because it's in the first quadrant, and the other answer is going to be in between 90 and 180 because it could also be in the second quadrant. Okay. Then what you do is, once you've determined the possible quadrants and you've made the angle x, you find alpha. How? By taking the inverse of the positive value. Now here, since it's already positive, you don't have to worry about it. But what you'll do is you'll take sine inverse of 0.5, which is 30. So what you found is basically the basic angle, or alpha, which is the angle that's formed between x and the horizontal axis. So here is alpha and here's alpha. Then you find theta or x depending on the range and depending on the direction, which you will determine with the help of the range. So because it's positive, that means you will measure in an anti-clockwise direction. So you'll start from 0, you'll keep on going till you reach this angle, which means it's 30. Then again, you'll start from 0, you'll keep on going till you reach this angle, which means it's 150. Okay, and then you can always cross-check. How? By finding out sine of 30 and sine of 150 and see whether it's equal to 0.5 or not. Okay, just like here, how can you cross check this answer? X equals to 2. You can plug this back into the equation and see if 3 power 2 is actually equal to 9 or not. So just like that, you can check this also. Okay, so this is just like scratching the surface of trigonometric equations. Things are about to get a whole lot complicated. I'm not trying to freak you guys out. I'm just trying to tell you guys that in the next couple of classes, make sure you bring your A game, you are attentive, so that you don't miss any of the key concepts. Okay, so what we're going to do in the next class is that we are going to solve some more trigonometric equations. Okay, and then we're gonna, if time allows, we can start graphs as well. Okay, how did we know it's in the first and the second quadrant? We know that because sine is positive. That's how we know that it's in the first or the second quadrant, because sine is positive. Okay. What if it was negative? If it was negative, it could have been in the third or the fourth quadrant. What if it was cos, which is equal to minus 0.5? That means it could be the second and the third quadrant. Remember ASTC, guys? All science teachers are crazy. ASTC. Or add sugar to coffee. And there was something else as well. Yeah, so that's AS. Yes, or that. All silver teacups. Nah. Advanced students think critically. Advanced students think critically. That's not too bad. That's not too bad. All silver teacups. I don't know if that helps you remember it, then go ahead. Sir classes. Yeah, I saw this in the book. All students trust Cambridge. Okay, so let's keep it till here only. Inshallah, we'll pick this up on Thursday. And on Thursday, we're going to dive deeper into trigonometric equations. And we're going to do some questions in degree mode. We're going to do some questions in radian mode so that we have a taste of both simultaneously. And yeah, so I'll see you guys on Thursday. Take care. Allah Hafiz.